My name's Rob Tappenden. I'm part of the product team for Tetration at Cisco. And between myself, Tim Garner, and Remy Philippe, we're going to walk you through protecting today's applications with Cisco Tetration. But really, before we look at today, we're going to take a little step back into the past. So some 10 years ago, 20 years ago, we were building networks like this. So 3-tier hierarchical networks, layer 2 at the access, providing connectivity for servers, providing data center applications. Now, we would have a security layer built in there, those firewalls and security services at the edge, and they did a fine job of securing the traffic, which in those days was primarily about north-south traffic coming in and out of those workloads, in and out of the data center. Now, as we've moved forward, we've seen a lot of change. We've seen changes in the way networks have been built, new fabric architectures come into play, virtualization changing the way that applications are actually delivered in these environments. And we've seen changes in the way security is delivered here as well. So those security services now in the form of next-gen firewalls providing high throughput security services distributed across this fabric, providing not only the north-south security, but also the east-west security that we would expect. But of course, the world today is much more than that again. So we do still have those mission critical applications running in the data center. They're virtual, they're running on containers. They're still running in bare metal as well. Those applications are still there. But more and more, we're seeing applications in cloud, one or more public cloud instances. So the applications themselves have changed. The infrastructures have changed. We're seeing more microservice-based applications, and all of this requires more connectivity. It's more dynamic, and it's continually changing. So some of the challenges we've had with securing these environments, the way that we've done it traditionally, is really starting to hit a few challenges. Those challenges are where to place those security enforcement points. How do you actually segment these environments and doing it in a way that's consistent? How do you have a consistent policy so that between your data centers, your cloud, you've actually got the same approach being applied and a consistent policy, and you still get to actually see what's actually going on. This is quite a difficult thing to do. So we need to look at new ways that we can actually address those, remove those bottlenecks, and really put the enforcement points for policy and segmentation right where it needs to be. So today, this really sort of has a number of key requirements. We need to be able to deliver security at speed. So no longer can we afford to wait days, weeks, or months for security changes to take place, right? If we're rolling out a new application, the security needs to come at the speed of the application. We need to have an approach that's consistent across any of these environments. So it shouldn't really matter if my application is being deployed in my, my on-prem data center or in the public cloud or across different environments. I need a way to have one consistent policy that's delivered and is actually securing all of those environments in the same manner. I need a policy that's dynamic, that can adjust to change. So again, this sort of comes back to the speed of delivery. I want something that can actually move and change and evolve as my applications, as my environment actually changes with it. And this all needs to happen at scale. We can't have those points where we're worried about bandwidth issues, performance constraints. We've certainly got very capable next-gen firewalls that can handle a lot of bandwidth, but if we can start to distribute some of that enforcement of policy, of the security policy down to the actual workloads themselves, we can overcome a lot of those constraints and actually get a whole lot of benefit through distribution of that functionality. To do it in a distributed manner means we need centralized control. We need one place that we can centrally define and model the policy that we actually want to have deployed, and then use those distributed enforcement points to actually deliver against that. Now, here we're talking about segmentation. We're talking about micro-segmentation. This is something, if we sort of step back in time, we've seen the evolution and the ability to actually do micro-segmentation in different places over time. But what's really been lacking are the tools that actually help us to actually deliver that effectively. Visibility is the starting point for that. With full visibility, we get to understand the communication patterns. We get to be able to define what a policy should be for a given set of applications. That's been one of the greatest challenges to actually effectively deliver microsegmentation over the past few years. With the visibility, we get to define policy, test that policy, and ultimately, once it's enforced, and we do that with a low risk because we've actually seen exactly what's going on, we can then make sure that any subsequent changes are addressed in that policy itself. So again, continually handling the changes in these environments and making sure the policy remains as it needs to be to secure the applications. This is what then leads to zero trust microsegmentation, being able to define a least privilege policy that ensures that if an attacker is able to breach one workload that's part of my application set, that they're not able to move laterally beyond that. We're trying to reduce that attack surface and really make an attacker's day as hard as possible so that they're restricted. And just keep in mind also that this is really a bi-directional segmentation concept. We're distributing enforcement, and we want to be able to protect workloads both from any attacker coming in, but also if they're in, from being able to actually get out again. So let's just take a little look at this a little further and how Cisco Tetration is actually built to deliver against that. So we see in these diverse environments that we actually need to protect. And Cisco Tetration is that central policy platform. That is supported by agents. Now, we talk about distributed capabilities. This allows us to actually take the full visibility, to each and every workload, which means that no matter if it's in the cloud, a virtual machine, or bare metal, we will see all traffic going in and out of that machine. So that gives us that full visibility in near real time, all stored in that Tetration platform. On top of that, it also provides the ability to enforce the policy. Now, as we go through the different sections this morning, we'll see with both Tim and Remy how we actually go about developing the policy itself. And I'll talk a little bit and provide an introduction in terms of how a policy is actually being delivered and enforced in these actual machines themselves. Now, the agent itself doesn't perform the enforcement as such. It's really controlling the local host operating system firewall. So we maintain control, ensure the policy itself, as determined by Tetration, is being enforced, and make sure that's always retained. On top of that, on top of the enforcement point of the agents, we can also support enforcement in other places, whether that be in your application delivery controllers like F5, or in some security infrastructure through an orchestration layer. And we do that through a streamed policy output. So the same policy that we're custom computing for each and every workload, we can also provide the complete policy set so that it can be deployed elsewhere for that consistent policy enforcement layer. Now, I mentioned earlier in terms of the requirements here that we are trying to deliver a dynamic policy model. Dynamic policy model means we're able to step back from traditional networking constructs. Yes, we're still talking about IP connectivity, machine-to-machine communication, but the policy itself doesn't need to be written in those terms. It doesn't need to be written in terms of subnets and VLANs and so on. It can be written in a way that's much more understandable to us as humans, and it can use context. The context we get from existing records, existing systems, things like orchestrators, where maybe workloads are being tagged with a certain set of characteristics. Could be coming from a CMDB, if that's a valuable source of information. And I know a lot of organizations are really focusing on building that out. And day one, it may not be as accurate as certainly they hope it to be, but part of this process is the learning process as well, how to actually facilitate an improvement of that data set and build it out over time. IPAMs, so IP address management systems, have valuable data as well. So things like what are the locations of the various subnets? So where are these machines that we're trying to secure? User and endpoint identity and other context can come from authentication systems, network access control, and finally, we've also got the ability to bring in context from other security systems in the environment. So we'll see some examples of the kinds of policies that we can actually build out here, and how we can leverage really each of these in turn to help facilitate some policy that we'll be able to enforce in a way that maintains that dynamic nature going forward. So we bring all that together. That gives Tetration the tools it needs, the full visibility to run through the real key lifecycle steps of any segmentation policy. We need the initial discovery. Now, as you'll see as we go through, it's not purely about discovery, it's about a combination of things that come together to make sure that you've got an effective, secure policy set. But in most cases, in many environments, discovery is key because it helps to unravel the 10 years of infrastructure connectivity that is running in those existing environments that is fairly poorly understood. So it gives you the tool set to actually get that clean and in it to a point where you can effectively and confidently enforce it. The key there is nobody wants to break applications when you secure them. That's one of the reasons why security is, in many cases, slow to respond. There's a lot of checks and balances that need to take place to make sure that any change is going to have a positive effect. So this really gives you the tools to make sure the policy is right when it's discovered, to validate that through simulation, and that's both historical as well as forward-looking. How do I make sure, again, that I've catered for all of the different nuances within an application and make sure that it will actually take into account the weekly or the monthly batch processes that occur. The enforcement of that policy is the key, and we want to, again, achieve that with a minimum of risk to the applications and make sure that it is as tight as possible. And then finally, ensuring the compliance of that policy. This is the post-enforcement piece. Now, there's no reason why we want to simply just turn off visibility once the policy is enforced. It's critical we keep watching, we keep looking for change, because that's where we see indicators that maybe a breach has occurred. Maybe there has been a change in the flows of the application. All these things have are really part of that lifecycle approach to policy. So the context, all of this really comes down to how does an organization actually define their own world, their own workloads. Every organization is different. They've got different sets of data, different confidence levels in that data, and they need to use this in a way that's meaningful to them. So we need some flexibility there, because not every customer is able to just define these 3 or 4 elements and then have that map and completely map their world and define a policy. The starting point here could be as simple as location. I've got workloads in different data centers. I've got users out in my campus environment. I've got workloads running in the data center. Where are they? How can I actually build a model that understands the location of those? I might want to have both the specific set of policy controls by location, and I may also want to associate role-based access control so that maybe a different group of administrators control a set of policy for my cloud workloads versus the data center workloads, as an example. I can build on top of that where I have confidence in the data to define application, the environment or lifecycle. So these are more the application-specific capabilities. And here is where I might also want to let the Tetration, in this case, help me to discover some of these pieces. If I don't know, for instance, what tier or role or service a given set of workloads are running inside an application environment, I can let Tetration actually suggest and make suggestions to me so that I can agree and sort of validate those and then lock those in. Organizations also have regulatory requirements. Now, this could be something like PCI, where I want to label or tag my workloads as whether they're inside a cardholder environment or if they're out of scope. Because again, I want to be able to define specific segmentation policies for these independent of their location, independent of what application they're running. These are strict mandated requirements that I need to ensure auditability and compliance for. And then finally, I've got many other things that I can actually label my workloads with that I can use for policy and other control points. An example of that is quarantine. So to be able to take a particular policy action, should I get a notification from, say, an external system that there's been some malicious behavior here. Maybe it's a vulnerable workload that needs to take, that we want to protect from exploit. So this is how we define context. It's not strict and rigid, it's flexible, and it's really based on what the organizations have. And the key here is that we don't need everything upfront to define the complete environment day one. This is really a case of starting with what you have, build upon that, and learn and grow as you build. With that data, with the context, that enables us to actually build a hierarchy. Now, in Tetration, and what I'm going to just present now is just an introduction into how we actually build policy through different layers and leverage a hierarchy so that we can actually have policy set that's not just purely about the application policy itself, because you've got many applications, you've got different ways that you want to apply policy across those applications through the context we just decided, we just discussed. But we want to build a hierarchy to do really a couple of key things. We want to be able to define policy at different layers, and the policy that at a particular layer will apply to everything within it. But we also want to give that role-based access control. So we want to be able to assign ownership, responsibility. This, along with distributed enforcement, gives us a distributed policy ownership. This is what also helps us to move faster, because if we can enable control of security policy within a given application or set of applications to the team that runs those applications or is building those applications, they can move much faster. But the key there is to put some constraints around what they can do. If we've got a set of zone-based policy that we want to enforce, if we've got a set of regulatory policy we want to enforce, we need to make sure that those policy teams with that delegated control can't step outside of those bounds. And we achieve that through the policy hierarchy. And I'll explain that in a moment. So first, we see everything. We can, based on location, we can identify we've got workloads, we've got users, we've got the internet. And as we step down, we're starting to just break this down into smaller components. So inside is everything inside our organizational address space. The simplistic view here would be RFC 1918 address space. Within that, though, we can separate out our campus and our users from our data centers and our cloud environments, because this is where the workloads are. Here, as an example, I've separated out data centers from clouds. You might have multiples of these. And within those, of course, we've got the applications themselves. So again, I'll have some policy applied at the individual layers here based on perhaps the location, but I'm into the application space now where I know I've got applications that could be controlled by different groups. I've got my IT services where Active Directory and so on is. I've got my other business applications here. Now, we can break that down even further. And again, this is really done through tagging and applying the context that we've seen earlier. Because within each application environment is most likely the different lifecycle environments. I've got prod and I've got dev. Do I want to separate those? Do I want to have distinct controls between those? Most probably. Within those, I've got the individual application groups and tiers. And here is where I finally reached the point of doing the deep microsegmentation, where I can actually now define policy that says these particular application components are only allowed to communicate with a given set of ports and protocols. I'll allow my users to access the front end of that application, and I'll make sure that everybody has access to the services and other components they need for those workloads to actually run in this environment. So each application has a policy. There are other policies that come together, and we'll just explore that in turn just to see how, when I step into a demo and I'll show you how this actually works and how we take that complete policy set and force it on the workload, how these actually come together. So we discussed different policy requirements earlier. So an organization might have zone-based segmentation. You can apply your zone-based segmentation controls not by which VLANs the workloads are in, not by which subnets they're in, but how they're actually labeled or tagged. So that context that's associated to those means that we don't really, at this point, it doesn't matter if they're all on the same subnet. We can apply specific policies based on the context. So here, I might want to ensure that non-prod is not able to talk to prod. So we don't want those dev users breaking our production database, as an example. We might also have a set of regulatory controls. If it's in the cardholder data environment, any machine shouldn't talk to something that is out of scope. Now, if we apply this as an overall security mandate, this means that nobody within each of the application teams or in any other policy setting can actually break this rule unless it's addressed at this level. So this is where we've got well-defined ownership of this high-level policy intent.
Yeah, so your policy enforcement, is it only tag-based, or can you use traditional constructs like VLANs and subnets as well? So
ultimately what we're doing with the tags is to interpret that into IP addresses and what IP addresses should be part of the different policy groups to enforce the policy. And what that means is that a policy can absolutely be defined by IP address. If you wanted to do it by subnet, for instance, that says anything in this subnet gets a particular policy result, you can do that. This is a way that we can actually use tags to break that down even further and give more flexibility so that you can write policy in a more natural way, but the end result is still in IP terms. So the answer is yeah.
Okay, and most of the public cloud providers have the concept of tags. Can those be inherited into Tetration?
Yes, that's a good point. And I didn't give specific examples, but in that architecture slide I had earlier, on the right-hand side where we had context or sources of context,
right?
Many of those are through direct integrations with those. So for AWS as an example, we directly integrate with AWS, and for any workloads that are in AWS, we'll pull in those tags dynamically.
Okay.
So workloads are deployed, they're tagged, they're discovered by Tetration, the tags are associated, policy is immediately delivered as part of that.
Okay, well, thanks.
Cool.
Sorry for interruption.
No, that's a great question. Thank you for doing so. So next level in, as we break the policy down, we also have the ability to define other broader sets of policies. In this case, this could apply to all workloads, You could also have specific policy sets that maybe are just for specific locations. Again, cloud versus data center. But here, maybe this is where we want to apply some rules that it's our common policy set for any of these workloads. Like, we know that we want all Windows servers to be able to access Active Directory. We've got a set of management and security services. We want monitoring to always get through. Again, these are the things that either are always permitted or always denied. But it's important to remember that what we're ultimately leading to is a policy set that will be based on an allow list. We do have some deny rules here, as you can see at the top, and these again are optional, but we do have a combination of allows and denies that can be built into the policy to again give you the ultimate result that you need. So if we define these rules, as you see here, authentication, automation, management, that means that any workload that's deployed inside this environment will automatically pick up those policy rules as well, which means we're really then down into the application space. And here's where, and both Tim and Remy will give specific examples of how this policy is discovered or how it is actually programmed in sort of different scenarios, whether that's more in terms of a discovered policy set or an API-driven policy set as part of a development pipeline. But we have an application policy, and this is where we actually deliver the detailed policy for the individual parts of the application. So we allow some users in, however we define users, into the front end, and then we only really allow what's absolutely required within the application for that application to function. Least privilege access, fully discovered by Tetration, with below that a deny for all else. Now, what's critical here, though, of course, is this is a very tight policy set. Before you actually want to proceed with this, there is again, going back to the life cycle of policy, we will want to test this. We want to simulate it. And this is part of the tool set of Tetration, is to take this well-defined policy and make sure that you have identified anything or any traffic flows that are outside of the policy, that you're able to remediate those, either the flows themselves or the policy itself. So when you go to enforce that policy and you take the resulting IP to IP communication policy that gets programmed into the host firewalls, you're confident that you're not going to break applications and that this will be successful. Beyond that, again, we continue to monitor that policy post-enforcement as well.
Do you have any sort of pre-canned policies or discovery for well-known apps or for common regulatory requirements?
Great question. So there are, so not in terms of like templates for the well-known apps. We today primarily do a discovery. So certainly there are well-known dependencies for the sort of well-documented applications, but there's often a case where there is exceptions, there's tuning, there's a lot of sort of change and variation to that. So we will always do a discovery of that and do a validation to actually build that policy set that can be then enforced.
Got a real quick question, Rob.
Yep.
In regards to if you're pushing for cloud-related resources, you're in AWS, are you guys modifying security groups, NACLs? Are you actually changing route tables? Because obviously that's very different for that environment. IP to IP doesn't really mean a lot in AWS in regards to how you're doing those controls, right? In terms of forwarding planes. So are you actually modifying the route tables in order to control flow between things?
No. So this is really it's sort of so we don't manipulate or change the actual infrastructure itself, regardless if that's the cloud or if it's in a data center. The forwarding, the routing, the connectivity is still a separate plane to this policy enforcement, which is done directly to the workload itself.
I have a question, Rob. Can we export or import the policies?
Yes. So the great question. The policies can be both imported and exported. They can be controlled through the UI, through the API, but also, as I mentioned earlier in the architecture slide, we have the ability to publish the policy. And what that means is, rather than have a manual, let's say, export step where I say I want to go and pull this policy out, Tetration, as the policy is changing and evolving, is going to stream that policy so that you can securely access the policy. And this is how we can actually then take that policy for an enforcement component. So this would be for, let's say, a security orchestrator to take this policy and deploy it into some other infrastructure, whether that's firewalls, networks, or cloud.
How are you typically handling things which agents can't run on, serverless like Lambda or other sorts of data coming in?
Yep. So it's a great question. The Remy, I might just ask you to just tackle that one if you don't mind.
Yeah, of course. Yeah, we do have a few things when it comes to those environments. So obviously, in a perfect world, everything would have an agent, but try to deploy an agent on a filer, you might have some problems. So the approach we have is the policy is actually streamed out through a Kafka feed that anyone can consume. So we are actually not binding it to Cisco or a specific partner or anything like that. You can take this Kafka stream and basically enforce everything. And as Rob mentioned, when he was explaining to Snehal how the system works, we try to translate everything to IP addresses, which means that you could have a tag in AWS that would translate into an IP address and then get pushed to, for example, ArgoSec, and have ArgoSec program all the infra, as an example around that. Is that what you had in mind?
No, more so for the discovery side of things, where dealing with what might be communicating with Lambda or what it's communicating with is more complex. Is that something where we might have to use like a stealth watch for its intercept to feed Tetration for that?
Hey, so we don't have to have the Tetration agent deployed everywhere to get flow data. So the agent is the primary way to collect information because it gets flow data and can also pair it with workload context and process information and so forth. But let's say for AWS, for example, we can consume VPC flow logs. And that's going to give you the necessary data to be able to perform analysis to work out exactly what's speaking to what inside AWS. You can do ER-span, you can do NetFlow, and those kind of other network-based ways of collecting metadata about what your workloads are doing.
Okay. So let's just jump into a quick demo. And again, this is really just to help facilitate the fundamentals so that it makes sense when Tim and Remy break that down even further and go into how the policy is defined. But if we take the policy layers that we'd previously discussed as an example here, we've got policy that is providing our zone-based segmentation, non-prod, can't talk to prod. We've got regulatory controls here. The CDE can't talk to out of scope environment. We've also got some other rules here that's just making sure that maybe there's specific port and protocol types that we actually want to eliminate from the network. We don't want to have any insecure protocols. So we can just make sure that there's an explicit set of controls to eliminate those. We've also got a set of rules here where we're just allowing those other common services. These are the things that we just want to always let through so that when we're doing discovery, it actually helps to simplify the results of those. If the things that are always permitted are already allowed, they don't need to be rediscovered. And this is also part of that initial process for customers. If they're going or starting with an environment that's completely unknown, often there are at least some common services. There are things that are well known. We can define them up front And because they're reused consistently across the environment, that makes that discovery process that much easier. So here, management services, security services, all just predefined, and they're able to then be reused within the environment. Now, in the example I showed earlier, we've also got an application running. We've got workloads in there. In this case, I've got a workload that's got a number of tags associated to it. So we know it's part of a particular application environment. It's a prod machine. It's got a particular PCI tag associated to it, and it's delivering a web service. Now, because we've predefined the rules around those, and we're actually enforcing those rules. So back here, these are currently our enforced policy set. That means that even though I haven't actually defined or enforced my application level policy, the actual machines there are already programmed with these higher order policy rules. So I have a Linux machine here. It's already got policy that's being programmed here. And this is the result of those existing enforced policies. Now, because I don't have an application policy, it still means that at the application level, this machine is able to talk to all of the other, for anything that we haven't explicitly denied is still allowed. So the lateral movement is still available at this point, unless it's either across zones or between the PCIe zones as we've already defined. So for instance, I can't ping anything that's outside of my CDE environment because I've got a specific deny rule that blocks that traffic. I can't ping a prod machine because I've got a rule in place that says non-prod can't talk to prod. But within my application, I actually can ping, or can sort of fully access the other machines that are in this application. So in this case, this could be the database server. It could be, in this case, it's a caching or application component. So we need to go the next step down. We actually need to go back to our policy and have a look at the application policy itself. And in this case, this is the commerce application. This workload we were just looking at is the web front end to that. And it's got a set of dependencies because we've performed a discovery here and we know how these things communicate. So we know web should only be able to talk on TCP/80 to retail and so on through the application.
Quick question.
Yep.
Who is defining the applications? As most environments have a brownfield environment with hundreds of applications. So yep. Who is defining those applications and basically those contracts?
Great question. So Tim will go into this in more detail as we get into the actual discovery piece. But so I mentioned earlier that we label workloads where we have context, and then we perform a discovery. So Tetration actually does the discovery for you to actually build out this policy so that we can define effectively a set of rules that's based on that we can then enforce. So this policy rule set applies just to these workloads, in this case, within this particular application, because we've scoped it. And when I enforce this, that these rules will be applied. But the discovery, I'll let Tim go into that in more detail. So here, and again, once we've actually done some validation, we've done some testing of that policy, we can actually go ahead and enforce it. So I'll just kick this off now. Oops, didn't want to do that. Get this latest version. No reason why we're doing that. And we'll kick off the enforcement. Now, I mentioned that policy that was discovered for us, we actually want to do some validation of. So before you actually go to enforce, there's an entire set of analysis capabilities here that allow us to actually track over time the behaviors in and against that policy. So every packet, every flow is being associated to the policy. If it's being permitted, we'll understand that. If there is an exception, we'll see what has happened and when, so that we can actually then modify or really understand the impact of that. Now, this, as an example, is basically a previous run. These are the same sort of the pings that I was just running, right? So we would actually see the pings being rejected in this case. We would see why. So what was the policy rule that made that decision? And then we can make sure that anything that's an exception to the policy, we know and we're confident when we enforce it, we're not going to break it. So with this in play, a fully tested policy, we've gone ahead and we've enforced it. We can now go back to our workload profile, and here it's just important to note that just as we were looking at the policies that were programmed into the actual workload through IP tables, we're also tracking the full policy set through Tetration as well. So just from an ongoing operational perspective, we do have full control of the agent, visibility of the policy that's deployed. We're tracking the actual agent itself for overheads. We've got the ability to upgrade those agents and manage the life cycle of those as well. So here, once these policy sets are combined and converged, we'll actually see the high order policy sets combined with the application policy, and then we'll actually see that the traffic flows that within the application where we were able to ping, let's say from the web front end to the back end database was previously allowed, that would then be blocked. That gives us control of lateral movement, able to actually give that least privilege to the workload itself.